simply a building block of a software application. So in the real world, an application consists of multiple classes, each responsible for a particular behavior in the application. And overall, all these classes together will provide the behavior expected from the application. Let's take a look at a real-world example. We all are familiar with the concept of blogs and posts. Let's say we would like to implement a web application as a blog engine. With a typical layered architecture, our software application consists of at least 3 layers: presentation, business logic, which is also referred to as domain layer, and data access, which is also referred to as persistence layer. In each of these layers, we can have classes, each responsible for something particular. For example, in the presentation layer, we can have a class like postView, which is purely responsible for displaying a post to the user. In the business logic or domain layer, we can have the concept of post itself. And finally, in the data access or persistence layer, we can have a class like post repository, which knows how to save a post to the database or load it from a database. A real-world application often consists of hundreds or even thousands of classes collaborating with each other. So for you as a C# programmer, it's absolutely crucial to understand classes and how to use them effectively to build a maintainable, clean, robust, reliable application. This lecture is pretty basic, but as we progress in this course, in every lecture and in every section, I teach you something new about classes. By the end of this course, you're going to learn a lot of materials about how to use classes and interfaces to build loosely coupled, extensible, and maintainable applications. So let's continue our journey. Now we know a little bit about a class. So it's a type that we developers define and give it a responsibility depending on the kind of application we're building and the layer that class belongs to. But what is inside a class? A class essentially has 2 parts: data, which is represented by fields, and behavior, which is represented by methods or functions. Here is how we illustrate a class in UML or Unified Modeling Language. UML is a graphical language for representing classes and their collaboration. And we use that as a communication tool as part of building software. So in UML, a class has 3 parts. The first part is the name of the class. Then here are the fields or attributes of that class, which represent data about that class. And finally, we've got the methods or functions, which provide some behavior. So in this example, our person class has fields like name, age, height, and weight, and it has methods like walk, talk, eat, and sleep. Let's take a look at another example. We talked about blogs and posts. So a blog post can have attributes or fields like title, description, and date time. And it can have methods like publish, like, or comment, which receives a message. A term that is often used with classes and sometimes used interchangeably is an object. But an object is fundamentally different from a class, yet a lot of developers, including myself, sometimes use the word object to refer to a class. But an object is essentially an instance of a class that resides in the memory. So back to our person example, if person is a class, we can have objects like John, Mary, and Scott. These are instances of that person. The person class or the person type defines the blueprint from which we can create objects. At runtime, these objects in the memory talk to each other, and as a result, we get the behavior expected from the application. Now let's see how we can declare a class in C#. Here's a basic syntax for declaring a class. Public and class are keywords, are reserved keywords in C#, and that's why I've indicated them with blue. Public is what we call an access modifier, and that's something you're going to learn later in this section. So for now, don't worry about it. Each class should have a name or an identifier, like person. In terms of naming convention, in C# we use Pascal case to name our classes. What is Pascal case? In Pascal case, the first letter of every word should be uppercase. We also have camel case, in which the first letter of the first word should be lowercase, but the first letter of every word after that should be uppercase. In C# we use camel case when naming parameters of methods, as you will see later in the section. So back to the declaration of our class. The class can have fields and methods. which we refer to as members of that class. We put members inside these curly braces here. We can declare a field for this class and call it name. Similar to the class, we start with an access modifier, in this case public, then the data type for that field, and an identifier. In the real-world applications, we shouldn't declare fields with public. This is purely for taking you on a step-by-step journey without confusing you with a lot of details along the way. As we progress in this section, you will find the best way to declare fields. Okay, now let's see how we can declare a method in this class. Very similar. So we start with an access modifier, and here's the signature of the method. So a method can have a return type. In this case, void means it doesn't return any value. Then it has an identifier, and here in brackets we can put any parameters that that method may need. Inside that method, we have the code. And here we can access any of the members of that class. So in this example, I'm simply using console.writeLine to display the name of that person on the console. Okay, now that we have a class, let's see how we can create an object or an instance from it. To do that, we use the new operator. So we start with the type of the class, in this case person, we give it an identifier, and then we use the new operator along with the name of the class to initialize an instance of that class. Note that here we are using camel notation for naming the person object. A shorter way to write this code is to use var. Var is a C# keyword. And the reason we use that is to save us from typing the full name of a class, because sometimes the name of the class might be quite a few characters. Plus, as you see, it's a little bit of duplication to repeat the name of the class in two places. So we use the var keyword, and the compiler automatically knows that this person object is of type person. Now that we have an object, we can access members of that object, like accessing the name field and giving it a value.